So as promised, here's taking a look at the indeterminate form 1 to the infinity. If we were really just looking at 1 to the infinity, it would be 1. But we are looking at a limit of something that is approaching 1. And so there's always some residual. There's something, added onto 1, even if it is very, 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 very small. That residual, when you raise it to the infinity power, usually adds on to the 1 and gives you something other than 1. And the best case scenario I have for that is the limit as x goes to infinity of 1 plus 1 over x raised to the x. We've looked at this limit many, many times. You should recognize it. If you don't, then I'll just let you be surprised at the end. But what we're going to do with this, and I guess let's first take a look and confirm our indeterminate form. If x is going to infinity, 1 over x is going to 0, and 1 plus something going to 0 is going to 1. Hence, our indeterminate form is 1 to the infinity. When I'm getting ready or feel like I'm going to do L'Hopital's rule, I always write IF and the form that I have, so I kind of have an idea of what to do. Because this involves an exponent, and if you remember back from logarithmic differentiation, if there is an x in the base and an x in the exponent, you have to ln both sides before you can differentiate. So before we're actually going to find this limit, I'm going to set this limit equal to some value, and you can call it anything you want. I'm going to call it y. And y is what we're looking for in this problem. And then to get the x down out of the exponent, I'm going to take the natural log of both sides. And so I have the limit as x approaches infinity. When I write the ln of 1 plus 1 over x raised to the x, I think y'all know by now that that x is going to go out in front. And that was our whole reason behind natural logging it, so I could get it down on the ground. So now we have a product, and let's take a look at what the limit of that product is. As x goes to infinity, I have infinity. And then as x goes to infinity in here, I have the ln of 1, which is 0. And so that's our product of infinity times 0. And hopefully you picked up last week without me being here that whenever you have an indeterminate form product, you need to turn that into a quotient so you can apply L'Hopital's rule. So I'm going to change that times x in front to 1 over x in the denominator. So instead of a product of x, I have a quotient of 1 over x, and that's equivalent. Now let's take a look at our new indeterminate form. So as x goes to infinity, the ln of 1 is 0. And as x goes to infinity, 1 over x goes to 0. And whenever we have 0 over 0 or infinity over infinity, we can apply L'Hopital's rule, which basically is going to say that the limit of this quotient that we currently have is equivalent to the limit of the quotient of the derivatives. So let's take a look at that. The derivative of the denominator looks a little bit easier to handle. That's negative 1 over x squared. Or in other words, x to the negative 1 is negative x to the negative 2. The derivative of the natural log function, I'm going to put the 1 plus 1 over x in the denominator, and then chain ruling, coming back and taking the derivative of what's inside, I get another negative 1 over x squared. So taking a look and simplifying that quotient, if I put this all over 1 and invert and multiply, I have the limit as x goes to infinity. The negative 1 over x squareds conveniently cancel. And so I'm going to take a look at the limit of 1 over 1 plus 1 over x, which is equal to 1. Now that's what the natural log of y equals, not what the limit itself equals, and so we solve for y, and the answer is E. Pretty cool. There's our proof that this limit does approach E. which I think is really awesome, and I hope to see you all on Monday and or Tuesday. I'm feeling much better. If you're listening to this video, I'll also send this to you in an email, but I have put all of the identities and the integral of secant and cosecant back on that sideboard. It will be up for you, excuse me, for the entire test. That's a little bit of a gift back since I was gone. I have posted the even solutions to the, I think it's 1 through 36 or 1 through 38, I'm not sure, of the review exercises. Those are on your web page and class page, and I will also send you an email reminding you of that. If you have any problems with the test being Monday or Tuesday because you've been out sick as well, please email me and we will make arrangements. Have a good day tomorrow. Hope you enjoy the Super Bowl or resting or whatever you choose to do on Sunday.